everybody. In this session, we are going to discuss worksheet questions based on the topic motion in a straight line. The questions are: two towns X and Y are connected by a regular bus service. A bus leaves in either direction at every t minutes. At every t minutes, bus starts from X as well as from Y. The two towns are connected. A man moving with velocity, speed here, in the direction X to Y finds that a bus goes past him every t1 minutes in the direction of the motion and every t2 minutes in the direction opposite. Then t is given by. So he is asking the relation between capital T, t1, t2s. What is t, what is t1, what is t2? That is, let me take a good color for us, yellow color. Yeah. Suppose X is a town, Y is another town. Buses are starting at every t time. Buses are starting on either direction, t time. Fine. So, speed of the bus, I am taking as capital V. Now, a man is moving in this direction, and after time t1 one bus is crossing. After time t2 another bus in opposite direction he is facing. So keeping these two in mind, speed of man is equal to Vm. It's convenient, Vm. Now see, at every regular time intervals, capital T, buses are starting. But after time t1, the bus is crossing the person, and after time t2, the bus is crossing the person in opposite direction. That's what given in the question. That means in the interval of capital T, how much distance the bus moves, that must be equal to the distance covered by the man with his relative velocity during the time t1 as well as during the time t2. Let me go in a systematic slow manner. That is, distance covered by the bus is equal to Vt. Very clear, simple, no? Distance covered by the bus, by the next bus starts, first bus will be at a distance of Vt. Cool? Yeah. Now this distance is nothing but distance covered by the relative velocity of the man in a time interval of t1, because after every t1 he is getting another bus. So I can write V minus Vm into t1. So how much distance the person covers with relative velocity in a time of t1 minutes, the same distance is covered by the bus in a time of t. So this can be betterly readjusted like this: capital T by t1 is equal to, I am just dividing with V on either sides, 1 minus Vm by V. Or I can write Vm by V is equal to 1 minus capital T by t1. Yeah. Now again for the another bus, another opposite directional one, S is equal to Vt, that is equal to V plus Vm, yes, because it's moving in opposite direction, into T2, yes. So this one also come as similarly, very similarly like this: capital T by T2 is equal to 1 plus Vm by V. Yes, so Vm by V is, I'm just taking these two equation and I will relate this t1, t2 and capital T. 1 minus here plus, okay. So Vm, this one comes this side, so 1 minus t1 by t came. So here 1 goes this side, so it will become capital T by t2 minus 1. Okay, let me write in a better way so that it looks good. So yeah, color change. This is 1 is sent there, t minus t2 minus 1. Now these two are same only, so I can write Vm by V, because we don't want Vm and V, because he is asking the relation between capital T, small t1 and t2. So 1 minus t by t1 is equal to t by t2 minus 1. So what will come? This is going to become 2 is equal to t by t1 plus t by t2. So obviously it is going to give capital T is equal to 2 t1 t2 by t1 plus t2. Is it? Yeah, you are right. So it could be an option of A. Yeah, it's an option A. Let me tell once again, here the point is this one. This is the important point. What is that? Distance covered by the bus during time t is equal to distance covered by the man in view of relative velocity during an interval t1 for the first bus x to y, and for y to x buses during the interval t2. That is the logic here. So one logic based question. Excellent question. Next we will see another question. This is a particle moves along a straight line such that its displacement x varies with time t as x is equal to data interpretation, and important points we need to recollect first: alpha t cube plus beta t square plus gamma, where alpha, beta, gamma are constants. V1 is the velocity of the particle during its journey between t equal to 1 second and 3 seconds. V2 is the instantaneous velocity of the particle at 3 seconds. The ratio is, okay, average velocity to instantaneous velocity is asking the ratio. Average velocity, instantaneous velocity. Wow. Average velocity is average velocity. So he is covering the entire concept. Average velocity is total displacement by total time. Total displacement by total time. Which time interval? T equal to 1 to 3 seconds. So that is equal to, you have to calculate displacement during 1 to 3 seconds. Displacement during 1 to 3 seconds. That means x3 minus x1 by time duration t3 minus t1. That means here only I will do x3 minus x1. x3 you substitute in it, alpha into 3 cube plus 3 I am substituting, plus beta into 3 square, yes, plus gamma. This is x3 minus x1 alpha into 1 cube plus beta into 1 square plus gamma, yeah, by 3 minus 1 only, no, 3 minus 1, that is equal to 2. Let me finish in this line only so that I can use better space. So yeah, this is 2. Okay, now 3 cube, that's going to become 3 3s are 9 3s are 27. Okay, 27 alpha, next 9 beta. Some patience is needed. My plus gamma minus gamma will go, no, why should I waste time? Minus alpha and minus beta. Gamma already cancelled, so I wrote somewhat a better way. That is equal to what you are going to get here, 26 alpha plus 8 beta by 2. Am I correct? Yes. So that is equal to 13 alpha plus 4 beta, right? Yeah. Next, he is asking instantaneous velocity in the other way. Instantaneous velocity is nothing but dx by dt, differentiation of that. So 3 alpha t square plus 2 beta t plus 0, derivative of x. That is instantaneous velocity. At what time you want instantaneous velocity? At a time 3 seconds. Yeah, my screen is somewhat bigger, so I have to move here and there. 3 seconds. You need to put 3 seconds here. 3 seconds. So that is equal, let me change the color completely, one color will not be good. So 3 alpha into 3 square plus 2 beta into 3. So it's going to become how much? 3 3s are 9, 3s are 27, 27 alpha plus 6 beta, right? Yeah. Now, okay, really, oh, he's asking ratio, average velocity by instantaneous velocity. Average velocity is 13 alpha plus 4 beta by, this is 27 alpha plus 6 beta. Okay. Let me check. 13 alpha plus 4 beta by 27 alpha plus 6 beta. Option C. Option C. Yes. Yes. You should encourage yourself after doing a problem. That will boost your confidence, dears. Okay. Let's go to the next. A man walking along a straight line with velocity 6 kilometers per hour encounters rain falling vertically down with velocity 6√3. At what angle the man should hold his umbrella so that he can protect himself? This type of problems can be solved in an easiest way like this. A man walking along a straight line with velocity 6 kilometers per hour. See, man is walking like this. Velocity of the man, which is equal to 6. I'm writing just number. 6 kilometers per hour. Okay. Because our mind won't accept. A science student won't write simply numbers. He will always write along with the units. Rain falling vertically down with velocity 6√3. Rain vertically falling with VR is equal to 6√3 kilometers per hour. Yeah. Now, at what angle, man? You see, always umbrella must be in a direction relative to rain velocity relative to the man, in a direction VRM. Remember, how rain appears to the man, in that direction one has to hold the umbrella. So that is equal to VR minus VM. So do you have VR? Yes sir, I have VR. He has given. Wow. Do you have minus VM? No sir, I don't have minus VM. Get minus VM. Yeah, minus VM. Minus VM, let me take a dark color. This will be minus VM. Opposite to that will be minus VM. This is minus VM. Number will be same, only direction is different. Number will be same, only direction is different. Now what you need to do? VR and minus VM must be added. This must be added. So whenever two continuous vectors are there, how to add them? You need to add like this. You need to create a new vector starting from first point to last point, and you need to draw the umbrella like this. Jui. So umbrella will be like this, and this is the direction of umbrella, right? So addition vector of VR and VM, of course minus VM, these two we are going to add. So he is asking angular. See, let me read. At what angle the man should hold the umbrella so that he can protect himself, this angle he wants. So I'm taking tan theta is equal to opposite by adjacent. So that is VR I'm going to take. So it will be VM 6 by 6√3. So 6 will go 1 by √3. 1 by √3 means tan theta is equal to tan theta 1 by √3 means implies theta equal to 30 degrees. 30 degrees with the vertical. So see, two 30s are there. We need to observe very carefully. 30 with respect to the ground. Cheating. 30 degrees with respect to the vertical. So don't get excited on observing the number. Observe all the options. I repeatedly tell in every problem, observe all the options. Don't get excited on watching number or only few words. Okay. Later you can select. So option B, 30 degrees with respect to the vertical. Okay. Let's go to the next question. A rocket moves straight upward with zero initial velocity and With an acceleration 20 meters per second square, a rocket moves straight upwards with zero initial velocity. Let me interpret the data. Initial velocity 0, acceleration of the rocket 20 meter per second square. Now it runs out of fuel and stops accelerating at the end of 5 seconds. That means this acceleration is carried for only t equal to 5 seconds. Later there is no acceleration. Force ceased to act. It reaches a maximum height and falls back to the earth. The speed when it hits the ground. Actually here we need to take up, he didn't give the acceleration due to gravity for these heights must be constant. In that aspect only we have to think. Here rocket accelerated up to some height. Later it flies like this. Have to think like this. Hope you understand. The dark one is accelerated motion of the rocket. Later fuel exhausted. Still it moves further some height and will fall back. Now let's read the last required one. It reaches a maximum height and falls back to the earth. The speed when it hits the ground is the speed with which it hits the ground. The speed with which it hits the ground, that we are going to find out. So once again read the question. Acceleration is given and initial velocity is given, and the initial velocity means here 0. After 5 seconds what will be its velocity? So what height it can go, and then from thereafter it has to fall. So here what is the velocity acquired? Here the velocity acquirement I have to find out. That is nothing but initial velocity for the further motion. Okay, so it accelerated for 20 seconds. It accelerated for 20 seconds. Okay, fine. So what will be its velocity at the end of this 5 seconds? Sorry, acceleration 20 meter per second square. What will be its velocity at the end of 5 seconds? So v is equal to u plus at, because net acceleration only has given. You have to feel like that, otherwise we can't go forward. 0 plus 20 into t value 5. So how much velocity it got? 100 meters per second is the velocity. So here velocity 100 meters per second. Okay, wow, 100 meters per second. So with 100 meters per second you have thrown. Okay, how much height it has already covered? H. How much height it has already covered? So this h is equal to, that h is equal to half at square. You can feel this h, ut plus half at square only. Ut plus half at square you can feel. So u value 0, half at square is 20 into what is t square? T 5 square. So 5 into 5. So 2 will go 10 times. 5 5s are 25 times are 250. So this is h. H is equal to 250 meters. Now you can feel like this. At a height of 250 meters, a body is thrown up with 100 meters per second. Then at what time it will come down? That time you can calculate. And with which velocity it reaches ground, that also can calculate. Further, how much height it is going to go? Further, how much height it is going to move? That h is equal to further height. Further height h is equal to u square by 2g. Further height is u square by 2g because it's a gravitational what you call motion. So u square is 100 square, 100 into 100 by 2g, 2 into 10. So 10 will go and this will go as 5. So 500 meters it further goes. So total h is equal to 500 plus 250, 750, 750 meters. So velocity of freely falling body v equal to root 2gh, right? 2gh. So root 2gh. 752s are 1500. Root over 15, 750 into 750 or 1500 and one more 0. So it can be solved to 2 zeros are there. We can take as 10 and 50. 25. We will factorize it. That will be better, right? Or otherwise you can observe from the options. First option ruled out. 15 under root will be 225 ruled out. 225 3s are ruled out. 5 5s are 25. 25 6s are, yes, 1500. So C option is better. So after solving this, you can get, or otherwise factorize and do it. It's not a big task. Meter per second. So option is this one. So I will tell you once again. At the end of 5 seconds, it reached to a position. So acquired some velocity. So height I found and velocity I found. There onwards, how much height it will go, that also I found. So total height 750. So total height time velocity acquired after falling through 750 meters is root 2 GH. I used that formula. Okay. Next, an ant starts from the origin and crawls 10 centimeters along x-axis and then 20 centimeters along y-axis. Okay. If you want, then I can draw it as a diagram. Okay. First, let me read the complete question. The dot product of the ant's displacement, so displacement vector we will write first. Displacement vector S bar is equal to 10 centimeter along x-axis, 20 centimeter along y-axis. Centimeter. Next, the dot product of the ant's displacement vector with the position vector of a point that makes with the x-axis and has a magnitude of root 2 centimeters. There is a position vector making an angle, how much? Displacement, the dot product of an ant's displacement vector with the position vector of a point that makes, oh here the angle is missing, with the x-axis has a magnitude of root 2 centimeters. Angle is missing, that I have to find out. 45 degrees, yes, this is 45 degrees, that is missing the question. It's a previous year question, no, I can recollect. So as it is 45 degrees, I can write it as its magnitude must be root 2 centimeters. So it should be I plus j, then how much it will be? Root 2 is the magnitude, right? That's why, and this is, yeah. And now what is he asking? The dot product of the ant's displacement vector and the position vector, whatever makes 45 degrees with the x-axis, has a magnitude of root 2 centimeter. Dot product is asking. S bar dot R bar. So 10 plus 20, that is 30. Okay, dot product. So both are under multiplication. So it should be centimeter square is the unit. 30 centimeters square. Okay, this 45 degrees you need to take up. Next, maybe typing wrong. Next, a rocket lifts off from the ground and accelerate upward at 1 meter per second square. Acceleration 1 meter per second square. And 20 seconds after, t equal to 20 seconds, lift off a piece breaks off from the bottom of the rocket. Okay. 20 seconds after the lift off, a piece breaks off from the bottom of the rocket. After breaking off, how much time it takes approximately to reach the ground? Similar question like previous. This is ground. Rocket is here. Now rocket will have a velocity, some velocity. That velocity only that piece is going to have. That piece will move like this then. Right? So he is asking how much time it takes to reach. I need to find out this velocity, I need to find out this height, then I can find out the time. That is the scenario what we are going to do. So height h is equal to half at square, because initial velocity for the rocket is 0. Half a is 1, t is 20. 20 into 20. So it will be 200, 200 meters. This is height. First of all, 200 meters we got. Next, velocity acquired by the rocket. Velocity v, that is equal to, v equal to u plus at I can use, u plus at I can use, u value 0. So a equal to 1 into t is 20. It will be 20 meter per second. Okay, fine. Now time taken. For that I told the equation, whenever a body is thrown upwards from a height, time taken for that formula is h is downwards. Acceleration due to gravity always directed towards the center of the earth. Initial velocity, it's with the rocket as upwards. So if you write an equation, h is equal to ut of gt square. Observe very carefully, I didn't write any signs, now I am writing sign. This is plus, I am putting this is minus, this is minus. That means minus 200 is equal to plus 20 into t minus half g t square. On solving for t, we will get t is equal to, how much we are going to get? We are going to get 8.5 seconds. Yeah. This is the method we need to solve this question. Next. This simplification you can do, it's a quadratic equation. Quadratic equation simplification everybody can do. Next. A car travels in a straight line along a road. The distance x from a stop sign is given as function of t by the equation x is equal to alpha t plus beta t cube, where alpha is this, beta is this. Let me write it. X is equal to alpha t beta t cube. Okay, calculate the average velocity of the car. Okay, fine. The average velocity means total displacement by total time. Total displacement means x for 4 seconds minus x for 2 seconds, because 2 to 4 he wants, by 4 minus 2. So put 4 in that. So 4 alpha plus 4 cube beta into 4 cube jna, minus, and 2 you have to substitute. 2 alpha plus beta into 2 cube by 2. So it's a simplification. 4 alpha minus 2 alpha and plus betas. 4 cube, 4 4s are 16, 4s are 64. 64 beta minus 2 2s are 4 2s are 8 beta by 2. So this is 2 alpha plus 56 beta by 2. That means 2 will go alpha plus this is 28 yeah. Now alpha value is 2 plus 28 into beta value 0.01. So it is going to become 2.28 then. Yeah, 2.28 meter per second. Option A. Yo. Next. So first you can simplify in symbols, later you can substitute. Okay. Next. Car driver is trying to jump across a path as shown in the figure up. Yeah. And by driving horizontally off a cliff x at the speed 10 meter per second. When he touches peak z, what would be the speed? Okay, this type of questions can be answered using conservation of energy betterly. No need of this way, but of course in any manner you can do. He is driving horizontally. Okay, horizontally. Horizontally he is coming with velocity 10 meters per second. That I can write as, here I will write ux is equal to 10 meter per second. Next, and the height covered h is equal to 100 minus 60, because from that point to this point, that's 40. Yeah, 100 minus 60 is 40 meters. Okay. Next, what would be the speed? That means see, by the time of landing he is going to have a vertical directional speed as well as horizontal directional speed. That is Vx is equal to ux only. Whatever is there 10, that only will be. And vertical directional speed we have to calculate. That is like a freely falling body. So using that equation we can calculate that, so that you can go for the resultant. So Vy is equal to, we have two formulae for Vy. Vy, we have two formula. One is time dependent formula, one is position dependent formula. Here position dependent formula only we can use. V equal to gt is there and V equal to root 2gh is there. Root 2gh is preferable here. Why? Because h is available. Root over 2 into g into h. Yeah, this is how much? 2 4s are 800. Okay, we will keep like this only, because somewhere I am feeling that it is going to be squared off. So resultant velocity is equal to Vx bar plus Vy bar is the V. So V magnitude is equal to root over Vx square plus Vy square. So that is equal to square root of Vx square is 100, Vy square is 800. So 900, 900 root is 30. Yeah, 30 meters per second. Option A. Next. A particle moving along x-axis has acceleration f at a time t is given by, this is acceleration, f is equal to f naught of 1 minus t by t. Whenever acceleration is becoming 0, the instant when acceleration equal to 0, the particle's velocity is. So at what time acceleration is 0? 1 minus t by t equal to 0. That means t by t is equal to t by t is equal to 1. So t is equal to capital T. Yeah. At this time, what is its velocity? He is asking velocity. For that, this is acceleration. Why shouldn't I write acceleration as dv by dt? I can write. So dt you can multiply. So you will have dv is equal to f naught of 1 minus t by t into dt. Now you can integrate for velocity. This is a procedure. This procedure you need to understand. Integration. Integration will give you v is equal to integral of f naught of 1 minus t by t into dt. So dt can be taken inside like this. Integral of f naught dt minus integral of f naught t by t into dt. Right? So this is just f naught t only minus this will be f naught by t into t square by 2. Okay. Now we need to substitute capital T. So velocity at capital T is equal to f naught into capital T minus, here also if I substitute capital T, 1 t will go. So f naught t by 2 will be there. 1 full minus 1 half. This language will connect us excellently. Full minus half. Yes. So this is f naught t by 2. Okay. F naught t by 2 is C, option C, option C, option C. Yes. 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 Next. The nature of graph drawn for a freely falling body with time on x-axis and speed on y-axis. Time on x-axis, speed on y-axis. The nature of the graph for a freely falling body. Freely falling body is first velocity 0. Next velocity gradually increases, and slope velocity by time, acceleration, that is constant. So straight line. So it should come as a straight line. Straight line starting from passing through horizon. Straight line. See, straight line passing through the horizon. Slope will give you velocity by time. dv by dt is the slope. Slope is equal to acceleration. Acceleration nothing but g, which is constant. So it must be a straight line. So straight line. Next velocity 0, and when t equal to 0, because it's a freely falling body, so you can have graph like this. So from this parabola is wrong and blah blah blah. Next, a stone is dropped from a height 100 meters while another one is projected vertically upwards from the ground with velocity 25 meters per second. A stone is dropped from a height 100 meters while another stone is projected vertically up from the ground at 25 meters per second. At the same time, The time in seconds after which they will have the same height is the time after which seconds they will have the same height. That means when are they going to meet? That is the question indirectly. One is dropped, okay, while another stone is projected vertically up, another one is projected. They are meeting, then only we can say that they are at same height, right? So meeting time is h by u, right? H is 100 meters by u is 25, that is equal to 4 seconds. After 4 seconds they are going to meet, that only meeting time. Next, a ball is thrown at a speed of 20 meters per second at an angle 30 degrees with the horizontal. U is equal to 20 meters per second at an angle theta equal to 30 degrees. The maximum height reached by the ball is maximum height. Oh, it goes to motion in a plane. No problem, we can. Ball throw at a speed of 20 at an angle 30 degrees with the horizontal. The maximum height reached, h is equal to u square sine square theta by 2g. It's nothing but vertical velocity square, u square by 2g only, h equal to u square by 2g only. So that is the logic. U is 20 into sine square theta, sine 30 1 by 2 into 1 by 2 by 2g, 2 into g value 10. 10, 0, 0 will go, 2, 2 also will go. So 20, 1, 10 will go, 10 by 2 is 5 meters. Next, a body is falling freely from a point A. A body is falling freely from point A at a certain height from the ground and passes through B, C and D vertically as shown in the, okay, A, B, C, D. Oh, fine. BC is equal to CD. BC equal to CD. Okay. The time taken by the particle to move from B to C is 2 seconds. B to C, 2 seconds. And C to D is 1 second only because it already falling, no, it acquires some speed. Time taken to move from A to B is A to B, we need to find. This time we need to find. Okay. A body is falling freely from A. Here initial velocity u equal to 0 we can take. First thing. Okay. Next. These distances are equal. So I would like to take the time t, suppose. Okay. Then velocity acquired up to here is velocity acquired up to here. V is equal to u plus at. So gt I can write gt, that is the velocity. Next, yes, now distance bc distance bt, s is equal to ut plus half at square. What is ut? U is gt, u, this is u, t plus half gt square, gt square. This is equation 1. Next, BC after CD. CD we can't have, no, so we can write like this. B to D I would like to write BD is equal to BD. BD I am writing. That is equal to UT, initial velocity GT into how much time? BD time. BD time is 3 plus half GT square, G into 3 square. So this is equation 2. Now we know that 2 times of BC is equal to BD. So 2 times of BC. Anyway, BC can be simplified BC. Yeah, this is 2GT plus 4. 2 ones will go, it will be 2G. Yeah. This is 3GT and plus this is 9 by 2. Okay, we'll put 9 by 2G only. Yeah, now 2 times of BC. So 4GT plus 4G is equal to BD, 3GT plus 9 by 2, 4.5 G. 9 by 2 means 4.5 I can write. So what I want T, okay. So GT is equal to 4.5 G minus 4G. That is 0.5 G, 0.5 G. G value 10 if it is, and then this will be 5 only. So T is equal, GG gets cancelled now, so implies T is equal to 0.5 seconds. Done. some thought should come within your mind, then you can get it. Yeah. Next. A car accelerates from rest with 2 meters per second square, accelerates from rest u equal to 0, data interpretation. With rest and with accelerates a equal to 2 meter per second square on a straight line path, and then comes to rest after applying brakes. Total distance traveled by the car is 100 meters. S is equal to 100 meters in 20 seconds. Total time is equal to 20 seconds. Wow. The maximum velocity attained by the car is equal to maximum velocity attained by the car. Vmax is equal to how much? That is the question. Actually, two formulae we have. Average acceleration is equal to alpha beta by alpha plus beta. Okay. S is equal to, we have S is equal to half at square, half alpha beta by alpha plus beta into t square. This is nothing but alpha is accelerated acceleration, beta is decelerated acceleration. Because car accelerates, later on applying brakes it decelerates also. This should be treated as alpha, and that is going to become beta. So I can use this first to get beta. 100 is equal to half alpha value 2 and beta by 2 plus beta into t square. T square is 400. Zeros will go. So it will be 2 plus beta is equal to 4 beta. So 2 is equal to 3 beta. So beta is equal to 2 by 3. Now you can go for Vmax is equal to, let me take another color. Vmax is equal to alpha beta by alpha plus beta into t. Alpha beta 2, alpha is 2 only, 2 into beta, beta is 2 by 3 by 2 plus 2 by 3 into t value 20 seconds. So this is 4 by 3 by, this is 3 2s are 6, 8 by 3. 8 by 3 into 20. So it's going to 3 gets cancelled, 1 by 2. So it's roughly 10 meters per second. So that is the answer. Yeah. Okay. Implies beta is equal to 2 by 3. Next. A particle moves along a straight line, okay, given the graph x-axis. Its position x versus time t graph is shown in the figure. Its average speed during its motion is, no time interval is given. Okay. Average speed. Let me take another color. You should be very careful, Chotus. Its average speed, not average velocity. If it is average velocity, that's different. Total displacement by total time. Average speed means total distance by total time. Total distance means all the distances you have to take up, all the distances. What is the distance between 0 to 2 seconds? 0 to 2 seconds. What is the distance? This is time. What is the distance 0 to 2 seconds? 1 to 3. 1 to 3 is 2 meters. Next 2 to 3 seconds. 2 to 3 seconds, 0 distance. Okay, it's at 3, same position only. Next 3 to 4 distance is 1, distance positive magnitude. And 4 to 5 seconds, again 1. So what is the distance? 2 plus 1 plus 1, 4. This is the total distance. So total distance by total time is average speed. So 4 by total time, how many seconds? 5 seconds of time. So 4 by 5 is 0.8. Yeah. Yes, 0.8 meters per second. Yes. Next. An object moving along x-axis with uniform acceleration has velocity v equal to 12 centimeter per second. Unit since is yes. At t is equal to 3 at 3 centimeters position. Okay. After 2 seconds, if it is at x is equal to -5, then acceleration is at x is equal to 3 centimeters. Yeah, velocity v is equal to 12 centimeter per second I cap moving along x-axis, and at x is equal to minus 5 centimeter, its acceleration is equal to how much? That's what I have to find out. Okay. Initial position is there, final position is there, so that we can have displacement s. S is equal to final position minus initial position. This is final, this is initial. Final position minus initial position is minus 8. Yeah, displacement is there. Initial velocity is given. That can be taken as initial velocity. So S is there, U is there, A we want. So how? And after 2 seconds, even time duration is also given. After 2 seconds, t equal to 2 seconds. So S is equal to ut plus half at square you can use. Ut plus half at square you can use. And he is asking A. S is equal to minus 8. U value 12. And t value 2 seconds plus half A into t square 2 square minus 8, and this is 24. And usually when instead of writing a calculated one, why don't you cut some numbers? That will be good now. Yeah, 1 2 will go, another 2 you can get. So minus 4 is equal to 12 plus 1 2 left from this, and 2 is cancelled. So 2a 2 okay, totally a only we have. So a is equal to minus 4 minus 12, that is minus 16. Minus 16. So option is A. Yeah. Acceleration is minus 16. Units. Without unit, a science student shouldn't give any number. Yeah. It's a multiple choice question. It's okay. Next. Car covers a distance of speed 60 kilometers per hour. Car covers distance at a speed 60 kilometers per hour and returns to the original point moving with a speed v. The average speed is 48. Average speed for equal distances is 2v1 v2 by v1 plus v2. That is average speed for two equal distances. Equal distances. If it is v1 and if it is v2, then 2v1 v2 by v1 plus v2. If it is 48 and this is 2 and here is 60 and this is v, by this is 60 plus v, after solving we will get v is equal to 40 kilometers per hour. Yeah. So 40 kilometers per hour. Next. A train 150 meter length is going towards north direction. Okay. At a speed 10 meters per second. A parrot flies at a speed of 5 meters per second towards south direction. Okay. Parallel to the railway track. The time for which the parrot flies alongside of the train is moving due north 150 meters with the speed, velocity of the train is equal to 10 meter per second, and a parrot is traveling with 5 meters per second in this direction. This is parrot. So the time for which the parrot moves along the train, that means time taken by the parrot to cover the train is, that is its meaning. So distance to be covered is equal to 150 meters. Total energy is converted into kinetic energy. Potential energy converted into kinetic energy. Then potential energy totally exhausted. Again kinetic energy converted into potential energy so that Ke is exhausted. Then that will come as total distance coverage here onwards. When will be potential energy going to become equal to 0? That is equal to 2 minus 20x plus 5x square. So on equating it to 0, 5x square minus 20x plus 2 equal to 0. So 2 5s are, I think it is not adjusting. So x is equal to minus b plus or minus b plus or minus square root of b square minus 4ac, 4 into 2 into 5. by 2a, 2 5s are 10. That is equal to 20 plus or minus 400 minus 2 5s are 10, 40. 400 minus 40, 360. 360 by 10. So 6 6 are 36. So root 10 will be there. So it is roughly coming as 3.9. No, I have a calculated value. Yeah, 3.9 correct only. It's roughly coming as 3.9. X is equal to 3.9. So if it is 3.9, it's already released from x is equal to minus 3. Maximum value of x is 3.9. So total distance will be this 3 magnitude of minus 3 plus 3.9. So that is going to become 6.9. 6.9 is 7. 7 the respective units, meters. No, so this will be, yeah. So 7 meters. Next. A body is tossing between two cars moving towards each other on a straight road. One car has a speed of 54 kmph. 54 kmph. Usually answer is also in meters. So I can convert it into 15 meters per second by multiplying with 5 by 18. And this is 36 kmph. That is 36 kmph. It is nothing but 36, 10 meters per second. Yeah. And the distance between these two is as given how much? 36 kilometers. 36 kilometers, nothing but 36,000 meters. Wow. And the bird speed is 36 kmph. Bird speed is 36 kmph. Okay. See here, the total distance covered by the bird before cars meet each other. So cars meeting time is first we have to calculate. Cars meeting is distance by relative velocity. Then cars meeting time will come. The distance is 36,000. By relative velocity is 15 plus 10 because opposite direction. So 15 plus 10 is 25. 36,000 by 25 is equal to some 144. 25 will go 14410. Then distance covered by the bird is equal to time into velocity of the bird. Time is 1440 into velocity is 10. This is conversion is 10 meters per second. So that is 14400 is meters. So option A. Yes, 14400. I repeat, their meeting time is distance by relative velocity. Two cars will meet. By that time, how much distance that bird will move? The distance moved by the bird is equal to time into bird's velocity. That is the logic in this question. Next. Good question. Two trains each are moving along two different tracks in opposite directions are put on the same track by mistake. Oh. On noticing the mistake, when the trains are 300 meters apart, 300 meters apart, the mistake is noticed. Okay. Apart, the driver starts slowing down the trains. The graph shown below shows the decrease in their velocities as a function of time. Okay, one graph only. Okay, another graph is also there. The separation between the trains when both have stopped is, separation is. Okay, fine. Initial velocity for this, why should I? Velocity is given, time is given, so that I can have displacement from that. But how? This area will give you displacement only, right? What is the displacement? Displacement traveled by the first train is, equal to half AT square, right? Half BH, triangle area, half BH, 200 meters it has covered. Okay. Similarly, distance traveled by the second one is this area. This area is half BH, half into base 8 into height 20. Magnitude is enough. 10 times. So 80 meters it has covered. So this has covered 80 meters. This has covered 200 meters. So total 280 meters. 280 meters they covered. What is asking? The separation between the trains when both are stopped 300 minus 200 plus 80. So how much it is? 20 meters is left out. Yeah. The trick, that sharp idea should get into your mind. That is the fun here actually. So sir, I will get that initial velocity, I'll take that time and I'll get the acceleration, and then I'll calculate s is equal to ut plus half a t square, blah 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 blah. Everybody can do in different ways, but how sharp you are thinking at the exam is important. Sometimes we too won't get an idea. Ideas will come fast by practicing more questions. Remember. Next, displacement x particle t equal to, okay, meter, one dimension under the action of the force, the related time t, then t equal to root x plus 3. The displacement of the particle when its velocity is 0. Displacement of the particle when velocity is 0. First of all, given function t is equal to root x plus 3. When will be its velocity becomes 0? That we have to find out. So t minus 3 is equal to root x. Differentiate it so that what will come, what I am trying to find out first, the displacement of the particle when its velocity is 0. Displacement of the particle when its velocity is 0. Okay. When its velocity is 0, what is the displacement? Yeah, its derivative will be 1 minus 0 is equal to derivative of root x, 1 by 2 root x into dx by dt. So this will be velocity by 2 root x. So velocity is equal to 2 root x. Velocity equal to 2 root x, or velocity equal to 2 root x is t minus 3. Root x is t minus 3, and the condition is when velocity is becoming 0, velocity becomes 0, that means t minus 3 equal to 0, t equal to 3 seconds. At t equal to 3 seconds, velocity becomes 0. What about its displacement? That is, put 3 there. So t is equal to root x plus 3. Here I am substituting 3 is equal to root x plus 3. We are going to get x equal to 0. So x is equal to 0. Yes. So velocity 0 time I found, and that time I substituted in x function. Yeah. Next, a particle starts from rest. Because the maximum speed of the particle will be maximum speed of the particle. So you have to use maxima minima concept for it. Actually, you need to obtain an equation for that. What is that? We have x by a plus y by b is equal to 1 as a standard equation, slope form, right? So what is on x-axis? Time by 10 seconds, plus what is on y-axis? Acceleration by 8 is equal to 1. So we got a expression. You can go for LCM and everything. So that acceleration, this can be 8t plus 10a is equal to 80. Okay, yeah. Now acceleration, 10a is equal to 80 minus 8t. So acceleration is equal to 8 minus 8 by 10 t. This is acceleration. Acceleration is nothing but dv by dt. Anyway, it's maxima minima we want, right? Maximum speed of the particle we want. Maximum speed of the particle. So this is dv by dt only, right? dv by dt. Velocity is already differentiated, so that I got this. If I equate it to 0, then what I will get, 8 is equal to 8t by 10. 8 gets cancelled, implies t is equal to 10 seconds I will get. So now on integration, I will get velocity expression. There I can substitute this 10 seconds. So on integration, dv is equal to 8 minus 0.8t dt. Its integration will be v is equal to 8t minus 0.8 t square by 2. That is equal to 8t minus 0.4 t square. Now substitute at t equal to 10 seconds. I will get the velocity. Velocity v equal to 80 minus 10 tens are 100. 100 into 0.4 is 100 into 0.4. So that will be 10 will go 40. So it will be 40 meters per second. Yes. So answer is 40. Next. In a metro station, a girl walks up a stationary escalator in 20 seconds. T is equal to 20 seconds. He can walk up. She remains stationary on the escalator. Then the escalator will take her in. T1 I will write. Okay, 30 seconds. The time taken by her to walk. Correct only. T1, T2 I can write. T2, this is T1. If it is on a moving escalator, then that is T equal to T1, T2 by T1 plus T2. Alone, if you stand on escalator, it takes 30 seconds. If you climb it, 20 seconds. So, if you are climbing on a moving escalator, then 20 into 30 by 20 plus 30. Ding, ding. So, it will be 4 3s are. 4 3 are 6 are? 5 1s, 5 4s. 5 4 3s are 12 seconds. Options? Yeah, yes, next. A particle shows distance time curve as shown in the figure. Okay. The maximum instantaneous velocity of the particle around the point is maximum instantaneous velocity. Maximum slope you have to check. Maximum slope, if it is a correct curve, it should be QR. Okay. But Q after a slight bend is there. So it depends. Actually, wherever the slope is high, that is having more velocity. Slope is less velocity. This is less velocity, this is high velocity. This is the concept. So graph is very diminished for me. Maybe in your printed book it's good. So it is R. At the place of R, it may be rising. Rising point you have to take. That means it should be steep up. Theta must be more. Next. A car moving with velocity 20 is stopped in a distance 40 meter. If the same car is traveling at double velocity, distance of stoppage for the same retardation. Same acceleration. For the same acceleration, distance of stoppage v square minus u square equal to 2as. So s is proportional to initial velocity square. If initial velocity is doubled, then stopping distance will be 4 times of s. Stopping distance will be 4 times of s. 4 into 40. 4 40s are 160. Yes. Next. If a body falls freely for 10 seconds, its average velocity during its journey is average velocity. Average velocity means total displacement by total time. Total displacement is equal to fell for 10 seconds. So, S is equal to half gt square by total time is 10 seconds t. So, tt once will go, half gt will be half into g value 10 into this is 10. So, it will be 50 meter per second. Yeah, this is the end of the show, and that means slideshow. Keep on practicing. We'll meet in the other session.